Habibi, i-WhatsApp meeting ithatha abantu abangaphi? Hmm? 30. Good day, guys. Can you hear me?
On my side,
Oh, okay. Thank you. I'm still just gonna give 2 minutes to those who still trying to join. We are about 38 now. Let's just give them 2 more minutes and then we can start. Is that okay?
Yeah, it's very curious.
Okay. At least you can see that they are coming one by one. We're just gonna give them 2 more minutes and then we can start. Okay, I think we can start now. For those of you who don't know me, who were not there when I was introduced in class, I am Dr. Khandis Notlolo, and I will be doing the other part in this course. And my profile is very simple. It goes as follows. I'm just gonna bring the calculator first. Okay. My office is upstairs, is F102. So if you want to consult, and of course when you are there, or maybe you can go to the HOD's office, because my office is close. Maybe he will show you, or the secretary, because it's just in that vicinity. So my profile is as follows. I studied my BSc, let me just put it like this, my undergrad at the University of Zululand. I was doing BSc Maths and Physics, and then I finished my BSc, and then I went to Rhodes to do my honors there. It took me 1 year, and then I passed that honors nicely with a distinction, of course. And then from my honors, and then I did my masters also at Rhodes University. And then after finishing my masters, I realized that it is actually more important to move forward. I mean, it doesn't make sense for you to get masters and also not move forward. So I decided to do my PhD. So just to specify, my honors degree and my masters were in applied maths, and then my PhD was in pure mathematics also at Rhodes, and I finished it. I graduated I think last year, and I became a doctor, which is NQF level 10. I am telling you this not to brag about my education. I just want you to know that it's possible for you to. You can also get your PhD in record time if you want to, of course. Does it matter if, let's say, with maths you actually got a level 2 or 1? It doesn't matter at all. What is important is your drive. Are you more driven enough to actually get an understanding of maths? So that is what is important here in this course. It has nothing to do with your background, that in matric I was not good in maths, or in grade 11 or I got level 1, or it doesn't matter. What is important is that, are you willing to actually move forward? And some students usually think that doing maths when they are doing auditing is not necessary. That's not true. I will explain in a moment that what usually happens is this. If let's say you are good, let's say you're good with all the other areas in your auditing, and now you happen to get a job, and then this job that you have, you become an auditor. You make a mistake, maybe just one mistake with calculations, you will be fired, because you can't make mistake with people's money. But if you are good with policy, you make a mistake with the other areas like policy and other things, you will find out that you get recommendations. So maths is the integral part, or is the important part of this course. So if you are doing auditing, you need to be good with maths. And you will find out that in the beginning, we usually start with fractions, decimals, proper fractions, improper fraction, all these small things. And you ask yourself, how does that actually have to do with what you are doing in auditing? So when you are doing these fractions, we know that we'll end up doing percentages. And when you are dealing with percentages, you will know that at some point that these percentages, sometimes you'll find out that there is an increase of 10%. So when you are doing your calculations, you need to take into account that increase. So it is very important to actually pay attention to what we are doing in this course. And today, of course, I don't want to end up talking too much and not talk about the main thing here. So today I want us to talk about decimals. And what are decimals? You have a question, or? Please try and mute the mic. Yes, thank you. So when you were doing the other parts with Mr. Obong, I know that you actually talked about fractions, right? And when you're dealing with fractions, you said that a fraction is always going to have a numerator and the denominator, right? And then if you have this, of course, the denominator cannot be 0, because if it's 0, this whole thing is going to be undefined. And we said that this number that is above this line here, you said that it was a numerator. And then this one that is below, you said it was a this is m, denominator. This is n. It was a denominator. And then after dealing with these fractions, you actually talked about a proper fraction, and improper fraction. So if you are dealing with a proper fraction, you still have a number that is written. We have a numerator and a denominator, but for proper fraction, this number here is small compared to this one. This one is big, that is in the denominator. And then when you are dealing with the improper fraction, I'm just trying to give you a summary here. I'm not going through everything, just to jog your memory. So when we are dealing with improper fractions, you are still having a over b, and of course this number here was actually big, and this one was actually a small number. And of course these numbers, they are whole numbers. So that is what was actually happening in this particular example. Let me just take this person who's trying to join here and see if we can help him or her to join. Is this now? Yeah. So we have this. Yeah. So that's what we are actually doing here. And then after dealing with these proper fractions and improper fractions, you talked about what you called it is a mixed number or a mixed fraction. But a mixed number or a mixed fraction, we said that is going to have a whole number here, and then here you will also have another number here in the numerator and another number in the denominator. So this one was a mixed number or a mixed fraction, whole number and then numerator and the denominator. Of course, this one here is a small number, and then this one here is actually a big number when you are actually having a mixed number. And we said that we can actually convert this number here to improper fraction, and we can also convert improper fractions to a mixed number. And the simple principle was this: you take this number, you multiply by the denominator, and then you add this numerator, and then you will get the numerator of the improper fraction. And then to get the denominator, you take the denominator as it is. So that's what you were actually doing. And then from there you talked about addition of fractions. So we talked about the addition of fractions, and then you talked about the subtraction of fractions. And then from the subtraction of fractions, you went to multiplication of fractions, right, of fractions. And then from there you talked about division of fractions. So what is important here is this: once you have understood these things here, you will find one important thing here, that when you are dealing with these things here, you will always gonna end up having a numerator and the denominator. So suppose that you have this and you understood it, and once you have understood this whole thing, you will find out that actually, if I want to talk in terms of money, and I want you to go and withdraw your money, let's say maybe your NSFAS is just giving you your 5,000, of course, as allowance. So if you have your 5,000 there, you cannot say that, no, the money that I received, it was 5,000 divided by 100 rands. No, we don't usually say that. You will usually find out that you either gonna have 5,000 rands plus some cents there, or just 5,000 and the cents are zeros there. So today what I want us to talk about is the numbers that actually contain this thing here, which is a dot there. Because when we are dealing with money, which is you will be dealing with we will be dealing with money in the next chapters, when we are actually dealing with annuities and other parts. You will find out that these numbers are actually playing a very important part in the course. So let me just do this, go back to what I had here. So we wanted to end up talking about what is the name of numbers that actually have the comma there. That is the main topic for today, which is actually decimals. Right. And another thing here that I want you to notice is this: whenever you have an improper fraction, you can always rewrite it in terms of a mixed number, and whenever you have a mixed number, you can always write it in terms of an improper fraction. And another thing, if let's say you know that you have 1 over 2, you can see this number is small, this one is big, therefore this one is an improper fraction. I want you to also notice that this number is still the same as the whole number is 0, and you have 1 over 2. And if you notice this here, you can see that if you multiply 0 by 2, you will get a 0. And then if you are adding a 1, you are getting that 1. And then you take this as actually the denominator. So please also notice that in matter of fact, this proper fraction can also be written as a mixed number or a mixed fraction. Let's talk now about these decimals. What is a decimal? A decimal is a way, let me try and make my writing a little bit better, is a way of writing. Please copy this down, it's important. It is a way of writing numbers, right? That includes a decimal point. What is a decimal point? A decimal point is that dot that I was talking about, that is here. So if you have 5,000, you know that your 5,000 is going to be 5,000, and then you have this cents here and you have a dot there. That is what we are talking about. It is a decimal point. This is actually the decimal point. So we want to write this numbers with a decimal point. What is a decimal point? What does it mean? This decimal point, we want it because we want to show values or numbers that are less than 1. That are less than 1. And another thing here, you will find out that it is this one I will explain as we go what it means, but for now just copy it. It is part of the base 10 number system. I will explain this as we go, which means it is based on powers of 10. So that is what a decimal is. So it is just a way of writing numbers that have parts that are less than a 1. Hope you have copied that. And then let me take an example here to actually show you what I actually mean by this. Suppose that this example here. So suppose that I have 1, and then I wanted to rewrite this 1 over a 10 here. So what is basically happening here? You can see that you have one whole number. So you have one whole number, and then you have 5 over a 10. So how do we usually say this thing here? We usually say that we have one whole, right? So we have one whole part plus, and you have this plus here, 5/10. So how does a decimal come into play here when it comes to this whole thing here? So if you wanted to rewrite this in a decimal form, this is actually written as 1 comma, this one is like this. If you look into this, you will find out that this one is actually 5/10 here. So because you actually have where is this now? Okay, no one is new here. Okay, so if you have this here, we want to have a way of actually writing this whole thing as a one number. So basically, if you look at this part here, you will find out actually that this part here is actually a value that is less than 1, and if I have 0 here and I have 1, this number here is always gonna be in between. I wanted to write this number as just one number because if, let's say, I had a number line here, I know that I cannot have this 5 over 2 in a number line. I have numbers that are in between 1 and 0. So what you actually do here, what is important is that because you have 5/10 here, what you need to actually notice here is this. What is 5? How many 5 out of 5? You have to ask yourself that particular question, that okay, I have 1 5, and then here I have 2 5. So this one is still the same as 1 over a 2. And then if you look into this part here, you can see a half is the same as 0.5. But we are trying here to get an understanding of how can we write this and in a way that is actually representing what is written here, because this is 5/10. So if you have 5/10, all you need to do here, you must realize that this is just 1 comma a 5. So the first number that is after the comma here is actually telling you this number 10th. That's what I want you to actually realize here. And also another case here, suppose I have a 0 plus let me say I have 0 plus 25 over, let's say, 100 here. You can see here I had a 10th here. I have a 10, so this one was a 10th. And then here I have 100 here. Because this one, we have a 0 whole. 0 whole is still nothing, so you only focus on the other part that is actually having something. So if, let's say, we were using this same principle of writing this, we would be saying this. We have a 0, let's say we have 0 whole. So we have 0 whole, but 0 whole is still nothing, so I cannot just include that. And I would be saying now plus, because of this plus, and say I have 25th in words. So 20 is like this. I have 25th, 100th. So we have an S here. So this one here, you will be saying 0 whole plus 25th 100. Because we have a 0 here, which is nothing, so we don't usually include that. So we just usually say that this whole thing here is just 25th 100, right? We'll talk about this because most people, they confuse this wording and say you said that, but now we're having this. In the memo, we're getting that there are some wording that are actually similar here. Is that for this part here, I want you to know that it is 5/10, and then for this one here, I want you to know that it is 25/100. So that's what is important here. And how do you actually rewrite this in a decimal form? Is going to be, you have this whole here, you have a 0.25. So that is what is important here. So 0.25 is just saying that you have 25th 100th. Now, most people usually think that whenever you have numbers in a decimal place, you read them one by one, right? That is also another way of actually reading this whole thing. So if, let's say, someone is saying this, I'm going to rewrite this again so that you can actually say it and then give you a nice overview of this whole thing. So this one, we said that it is 25, 25, just write it in words, 25 100. This is 100 here, so you say 100th, right? So it is 25/100. And then if, let's say, now you have this nice thing, someone might decide that, but say this is not how I was taught. It is still the same thing, but it is written in different words. So someone usually say that, okay, this one here, I am going to say that because this 2 here is the first number after the comma, and because of this, whenever I have a first number, just say it is the 10th. So someone might say that we have 2 10th plus 5 500 hundredth. So this thing here, 2500th or 2/10 plus 500ths is one and the same thing. So don't make that mistake. This and that is the same thing. I usually prefer this. The reason I prefer this one here is because it's easy for you to not forget. But most people usually prefer this whole thing here. So it's good for you to actually know both these two things. And then another one here now would be if I have, let's say I have 3,141. And how would you actually read this whole thing? So this thing is saying that you have three wholes, and then you can say that plus 1/10 plus you have 400. We have an n here. We have 400, and then plus 1,000. So you can either write it like this, or you can just say that I have 3 wholes, right? And then after that you can just say that and, or you can just say, let me write this, 3 wholes and 141. If you look into this here, how many numbers do we actually have here? So we have 1, 2, 3. So we will end up having 1,000. 141 thousandths. So this is one way, this is another way to write it. And of course, writing this one is fine and writing this one is fine, but I want you to know them both so that if you have multiple choice questions and I only give you these types of writing these things, you know actually that this is the correct one if this is the only type that I have and this one is not there. And also if I have these types, I want you to also know that it is one way of writing this whole thing. Okay, let me do this here. Someone is trying to come here in this meeting, but let's just assume because they are late. Okay, we already established this and we already talked about this whole thing here. What is important here, these are the keynotes that I want you to know. The first keynote is that the number before the decimal, I'm gonna say it's a decimal point or decimal place before the decimal point or the dot there is a whole, right? So it is a whole number part, and then the number after the decimal point, that number after the decimal point, this one is usually just, we usually call it a fractional part. What is important here is this. I want you to understand that when I have 3 comma this whole thing here, I am actually saying that this one is simply the same as I have 3, which is this whole number, and then plus, and then I have 141 divided by 1000. That is what is important here. So this is the same as that. So once you have this, and of course we have this, now I want us to talk about something now that is actually important. Let's just say now I have values here so that you don't get confused, and these values here I have, let's say 0,1, I have here 0,01, 0,001, and then I have 0,0001, and then here I have 0,000 001, and then here I have 0,00001, and then here I have 0,00001. 1 2 3 4 5 6 1 2 3 4 5 1 2 3 4 5 4. Okay, 0 1 2 3 4 5, and then here I have a 6. I'm gonna stop there. If you look into this here, whenever you have a decimal, this one here, I'm gonna call it a position. Position of I have position of digit after the decimal point, right? And then here I want you to give you a name. So if you look here, I'm gonna place a line here to divide this, and then here I'm gonna place a line to divide this, and then of course here I'm gonna place another line to divide this, and then I'm gonna use a red there. So if you look here, we're supposed to have a decimal. A decimal is going to be a number like this. You have a number before the comma, and then you have numbers after that decimal place or the comma. So you have these nice things there. Now if you look into this, just after this dot here, this is in the first position, this one is in the second position, this one is in the third position, this one is in the fourth position. Guys, can you see the screen?
Yes, sir.
Okay, thank you. So this is what the only thing that is actually disturbing us is when some of the people are late. So every time I'm going there, it takes time for this to load. So that's the only issue we have. But other than that, I think we can all see. So if you look into this number here is in position number 1. So here we usually say that it is in the first position, and this one here, it is in the second position. This number here, it is in the second position. So we usually say that it is in the second place or second decimal place or second position. That's what we usually say with these numbers. And if you look at this one here, it's not here in the first, not in the second, so it is in the third. So this one, it is in the third decimal place, right? And also here, first decimal place, second decimal place, and this one here, this one here, it is in the fourth decimal place. So we usually say fourth decimal place, and this one we usually say it is in the fifth decimal place, and this one it is in the sixth decimal place, and this one it is in the seventh decimal place. And how do you name a decimal of this kind? We have 0,1 here. So if you have a 0,1 here, so let's say we have only this one here. So what is important here, if we take track of this one here, you will just say it is 1/10 or it is a tenth because it is in the first position. What do I mean by that is that these tenths are coming from the fact that we are dividing by 10 raised to some 1 here. So this first position is usually there. And then when it comes to this one here, you will find out that this one here is in the second position, or it is in the position. We still have a 10. We are always using 10, and we have a 2 there for the second position. And if you look here, I have this calculator here so that you can know what I'm doing here. If I have 10 and I raise that to a 2, what is that? That is 100. So this one here, we usually say it is, we have an S here, it is 100. 100. You get what I mean? So it's going to be 100. If this was 2, it was going to be 200. And then in this position here, because if you are placing a 3 there, you will find out, because these positions here are actually becoming a number that is up there from 10. So that one, you can see that is going to be 1,000. So we usually say this one, it is 1,000th. And then here, of course, from a 1,000, we usually go to a 10,000. And then from the 10,000, you know that for this one here, you will end up having 100,000, right? And then from there, you can say that you have a millionth, and then here it will be a 10 million. This is million. So that's how you go here. You start with the 10th, you go to 100th, you go to 1,000, and then you go back 10 thousands, and then you go to 100,000. When you are supposed to be at 1,000, that's when you start with a millionth, and then from millionth you go to 10 millionth, and then after that you go to 100 millionth, and then you go all the way down there. So this is the summary of how you actually say these numbers in words. So suppose that now we talked about that, and you know that if I'm giving you 3,141, so you know that this one here is in the first position of first decimal place after the comma. So this one, you will still start with this one and say 3 wholes. So you're gonna have 3 wholes, and then after that you put a plus. You say this is going to be a plus, and then for this one here you're just gonna say 1/10. And then when you are going for this one is in the second place, so you can say again plus, and then we are going for this one here, which is in the second place. A second place means 100, so you will say 4 100. This is not the right one. This is supposed to be 400. And then you say plus again for this one, which is in the third place, whereby you're gonna say 1,000th. So that's how you write this according to this number system here, or how you can pronounce this using the position and then using this one over here. And then now that we're actually having this here, we can actually now start talking about, if let's say I have a decimal place like this, I want you to know that this decimal place is the same as 0,500. So as long as I am adding zeros here, it's not going to change this. And even if I'm adding more zeros after this number, it's still the same thing, because 0 is nothing. You get what I mean? I hope you can get this. And also, if someone is saying I have 0,5, I want you to know that because this one, we usually say that this one is, we have 0 whole. So this one, someone might say that it is the same as just 0,5 without placing a 0. This is still correct, so that when we are doing percentages and you are seeing me punching a calculator, you must know that 0,5 is still as 0.5, or 0,6 is still the same as just 0.6. That's what is important here. So if you look at 0.6 here, you will find out that it is the same as 0,6. So I want you to know those things here. And also, if you're looking at 0,5 and then I add the zeros at the end, it doesn't matter how many zeros are there. I want you to know that this is still the same as just 0,5 without those zeros. But if I have a 0 in front, it matters. So what is important is when the zeros are after the number. That's what I want you to know, so that you don't get that confusion there. So what is next that I want us to talk about? We're just going to talk about the conversion of decimals to fractions, and also from fractions to decimals, and then we will call it a day. And then tomorrow we'll talk about the addition of decimals, multiplication, subtraction, and also division of decimals. Right. Before I do that, let me check something here, if we are still in the right time. Look into this. Oh, we're still within time. Okay, let's go back. Yeah, so we are having this nice discussion here. What is important is that we will need this understanding of decimals when we are dealing with finance. Let me just put it like that. And we need this understanding of decimals when we will be doing stats at some stage, but not in this semester. And then we also need these decimals to actually understand numbers between two whole numbers, because a fraction is not actually telling us what we want to get in a number system. Because if, let's say, you are having 25 divided by 100, we can't really place that in a number line, but once we have a decimal, then we'll be able to place that in a number line. So I want us to talk now about conversion of decimals to fractions. When I am saying fractions, I am actually saying that we are converting a decimal to either a proper fraction or an improper fraction. That's what I mean by a fraction here. And then these are nice examples. These things are important because they will be there in your test and also in your exam. They are very, very, very important here. Suppose that I'm saying this, express the following, right? I want you to express the following decimals as fractions. Another question will be convert the following decimals to fractions. So this means the same thing. I want you to know that. So the first one here, let me use a green here. I want you to convert 0.3 to a fraction, right? So what I said here is this thing here. You know what is going to happen here. I'm going to just punch it here because we have a calculator here. So we have this calculator here. When I'm placing equal here, you will see that is 3/10. So this whole thing, whatever we'll be doing here, we're supposed to get this 3/10. But we are trying to solve this without a calculator. That's the main idea here. So once you have this here, how can you write this in words? You can see that there is nothing before the comma. It's just a 0, which means we don't have any whole. We only have a number after the comma. So because we have a number after the comma and it is the only number that we have, so this number here, we can just say that this number that is after the comma is just 3. We know that it is 3, right? So 3, and then it is in the first position, so we just say it is 3 3 10. What am I doing here? It is 3 we're supposed to start with an n here. 3/10. Yeah, so this one is just 3/10. And now, as you can see here in the calculator, it is 3/10. Now, how do we move from this 3/10 to actually that 3/10? You can see that is 3/10 or 3/10. That's where the wording is coming from this 10 here. So let's look into this and find out how do we get this. So the first thing that I want us to realize here, we want to convert this first to a mixed number, so that we actually have a whole number, and then in the denominator here we are actually having a denominator that is nicely sitting there. So because we are having this, and then we will actually convert it later to actually a proper fraction or an improper fraction. That is the conversion, because this is what we are actually looking for. This is way too easy, guys. You don't have to worry much that I'm making this so difficult for unnecessary. No, this is not hard. So this number that is before the comma here, I said that this number here is supposed to be actually the whole number, so it is the whole. So because we have a 0 here, the number that is here is a 0. And then when we are looking for the number that is actually in the numerator here, what you need to do, you just take this number after the comma as it is. So the number that is after the comma is just a 3, so you place that 3 in the numerator. And then what is going to be the denominator? The denominator is always going to be a 1, so you're always gonna have a 1 there, and then you add some zeros there. How many numbers are after the comma? After the comma, we only have one number here, so that number is telling us that the number of zeros we should have here is 1, so the denominator is going to be a 10. I'm going to repeat what I said. This number that goes here is going to be the number before the comma. If this number is 0, you place a 0 here. If this number is a 5, you place a 5 here. If this number here is actually a 10, you place a 10 here. If this number is 141, you place a 41 here. It is this whole number that is before the comma. And then in the numerator, you take this number after the comma as it is, you place it there as it is. So this 0 is there and this 3 is there. And then once you have placed that, we want to find the denominator. The denominator, you get it by you first place a 1 here. The 1 is always going to be there, and then the number of zeros that are here is going to be determined by how many numbers are after the comma. So because here the number that is after the comma is 0, so we're just gonna place 1 0. I mean, the number after the comma is 1. We have one number here, so we're just gonna have 1 0 there. And then how do we move here? Of course, you do the very same thing, that's saying 0 times 10. So 0 times 10, you know that 0 times 10, any number multiply by 0, you know that you are going to get a 0. This is what the calculator is saying. It's not my own thing, it's an us thing here. So this one is going to be 0 if you multiply these two, and then after multiplying these two, you add the numerator. So 0 plus 3 is going to be 3. The answer that you have, you just place it there. And then after that, you take this denominator as it is, so you place it there, which means now 0,3 is just the same as 3 over 10. So that's how you actually do this whole thing. And then let's take another example here, and then I'm gonna give you 2 minutes to actually do it. And then if you are done, please just raise your hand, or you can just place a thumb button to say that you are done, and see if we're getting the same answer there. So B is saying, I want you to convert 0,4, and this 0,4, I want you to actually write it in a fractional form. Please do it and see what you're actually getting. And then when you are done, just give me a thumbs up, or maybe you can just say so. Just open your mic and say, and then you mute it again. Try and do it. You are already done. Okay, so what we are actually doing here, okay, I can see. Okay, what we are actually doing here, the first thing that we wanted to do here, we wanted to actually convert this to a mixed number, or a mixed fraction. We have a whole number, a numerator, and the denominator. And then if you look into this here, the whole number here is just a 0, and then the numerator, of course, is that number after the comma, so that number is actually a 4. And then after that, you're gonna place a 1, and then you want the number of zeros that are here. How do you find the number of zeros here? You just count how many numbers are after the comma, and then we have only one number there, so you will end up having just a 10, which is just saying that, okay, we have this nice thing here. And then now we want to convert this to a fraction, just a proper fraction or improper fraction. And then you say 0 times 10, you know that is going to be a 10. 10 plus 4 is going to be a 4, and then you take this 10 as it is, so you place it there. Of course, if you look into this here, it says that 0.4 is actually the same as 4 over a 10. But now if you look at 4 and a 10, there is a common factor there. So if I'm pressing the calculator, it's not going to give me 4 over 10 because there is a common factor between 4 and a 10. So here you can see that 4 goes to 4 one time, and then in 10 it goes, but it leaves a denominator, it leaves a remainder. So what you actually do here, you just look at the factors of 4. You have 1, you have 2, and then you have a 4, and then this one does not go to 10 and not leave a remainder. So we're not gonna take this. And then if we are using a 1 here, 1 goes 4 times, and in 10 it goes 10 times, so we're still gonna get the same thing. So we usually take this one here, which is a 2. How many 2's out of 4? There are 2. And how many 2's out of 10? We have 5. So if you are having this, you still have full marks because we are just converting here. But in a multiple choice question, please and try and write it in a simplest form, which is that. I hope we got the same thing here, that our 0.4 is just simple as 2 over a 5. That is what is important here. I want to give you another example here, which is just gonna call this C, and I want you to convert 0.47. Can you try it? And when you are done, please give me the just give me a thumbs up. Just convert this 0.4, and then after that, this is going to be our D. Our D, I want it to be 0.763, and then after this D, we are going to have our E here, and then our E is going to be 1.25, and then after that we can go and convert the other way around, and then I can give you a homework and leave you alone. You are already tired. I mean, yeah. Can you comment your answer? What is your answer? Just open your mic and tell me. 47 over
100, say.
47 over 100. Did you punch a calculator? Yes or no?
No, say no, I didn't punch.
Okay, no, it's fine. Okay, what we are actually doing here is simple. We want to first convert this to a mixed number, and then from there we are actually converting it to a fraction. Then what we actually do here is simple. The number before the comma is just a 0, and then the number after the comma is going to be 47, and then here we're always gonna have a 1, and then the number of zeros is determined by the number of numbers that are after the comma. So the numbers we have here, you have 1, 2, so we are going to have 2 zeros there, and then after that, 0 times anything, we know that is going to be 0, and then we add in 47, so 0 plus 47 is going to be 47, and then we take the denominator as it is. In other words, this is just 47 over 100. You can test it if you want to and say you have 0.47 is going to be that. So that is what is important here. We have this one here is going to be 0.47 is just equal to 47 over 100. Anyone who wanted to tell me how to write this in words, can you open your mic and tell me what is this in words? Anyone? Just open it. Yeah. It is
410 plus 100.
okay. We have
7.
4/10. This is not right. So you are saying is 4/10 plus
700.
700. Hundredth. We always have that at the end so that you can see that what is actually happening here. We are not having 700. We have 4/10 and then we have that. Anyone who have a different answer to this? You can open your mic, is fine. Come on, guys. This one is saying that we have one position here, so it's 4/10 for first position. Yes, please. Someone is raising a hand. Omit and ngapai. You can unmute yourself and then say what you want to say. Ngapai? Okay. Jevu.
So we cannot say it's 0 whole plus 4/10 and 700.
Okay, let me go back. So you are saying here you have a 0 whole plus 47. I want to write this whole thing in words. Plus 47. This is supposed to be n 100. Is that what you are saying? Okay. What?
Yes, sir.
Okay. So this one here, this one is correct, and this one is correct. And the only thing that we usually, because this one is 0 whole, we usually don't include it because it's 0, so there's nothing there. So it's still fine, but that 0 we usually don't take it out. I hope you get it. That you can just say it is 4700. You getting it? So it's always going to be that. Okay, sure. So it's either you're gonna write it like this or write it like this here. Yeah, some people who are so perfectionists, they always want you to read this one by one, but now when there are so many numbers, it's kind of impossible to do that. This one is also a correct way to say it, so it's still fine. So what was the answer here? Can anyone tell me what was the answer? The correct answer? You can unmute yourself and then you give me the answer. It's fine. You don't have to be worried. You don't have to worry much that you might be wrong or anything. It's the main point about doing maths. If you want to know it, you need to get what is inside you out so that you can actually get the correct answer. It's the same thing. Okay, let me just leave it there. What is the correct answer here?
The correct answer is 763 divided by 1000.
763 divided by 1000.
1,000.
Okay, thank you very much.
Yes.
Okay, I wanted to see those of you who got a correct answer. That is not this one. Who have a different answer which is correct? If your answer is different from this and it happened to be correct, trust me, I will give you a 1000, a whole 1000. Anyone who have a different answer from this? You don't want a 1000? Okay, fine. I'm gonna keep my 1000. Thank you. Let's see now if this is the correct answer or it is not a correct answer. So what we do here, you know that you take the number before the comma and then you just place it there. So it is 0. And then in the numerator, you're always gonna take 763. And then in the denominator, you're always gonna have a 1, and then you count the how many numbers are outside after the comma. So you have 3 of them, so you end up having 3 zeros there. And then when you're multiplying 0 by anything, you're always gonna get 0, and then you add that number in the numerator. So 0 times anything is 0, plus that is, we're always gonna get that, which is 763. Let me make this correct. 763, and then in the denominator you take that as it is. So this one is actually the correct answer. So if you got something else, chances are you still need to work on that, on actually understanding what we are doing here. And then for this one here, what you do, of course, you want to first convert it to you actually want to convert it to a mixed number, and then you convert it to a fraction there. And then what is the whole number there? It is the number that is before the comma. Did all of you get an answer here? Just send a thumbs up button if you actually got it, or you can unmute yourself.
25 over 100, sir.
Okay, we are having a 25 over 100. Okay, I want you to also look at 0.25. What is the answer there? Let's start with this one. So if you want to actually deal with this one, you always gonna convert it first to a mixed number, and then after that you convert it to a fraction, right? So we want to find out what this is. So here we have a 0 there, which is a whole number, and then here we're always gonna take that number as it is after the comma. So you have a 25, and then here we're always gonna have a 1. We're always gonna have, let me write this normally. So we're always gonna have a 0, and then in the numerator we take it as it is, and then in the denominator we have a 1, and then the number of zeros is determined by how many numbers do we have after the comma. So we have 2, so it's going to be 100. 0 times 100, we know that is going to be a 0. 0 plus 25 is going to be 25, and then the denominator is always going to be that, so it's going to be 100. So this answer that you gave me is only for this one, where the number before the comma is a 0, but now the number is a 1. So here we're supposed to end up having a 1, and then in the numerator there we are actually taking the 25 as it is. Take that number as it is, and then actually when we are going now to the denominator, all you need to do, you place a 1, and then the number of zeros is determined by how many numbers do we have there. So we end up having 100 there, because 2 zeros means 2 numbers that are here. And then 1 times 100. What is 1 times 100? 1 times 100, we know that is going to be 100, right? 100 plus 25, so 1 times 100 is going to be 100, right? And then 100 plus the numerator, which is 25. So we end up having a 25 there. 0 plus 5 is going to be 5. 0 plus 2 is going to be a 2. And then 1 plus 0, because there is nothing, so it's going to end up having a 125 divided by 100. So this one here is supposed to be, so 1,25 is supposed to be the same as 125 divided by 100. Of course, here the highest common factor between 125 and 100 is going to be a 25. How many 25s do we have in 125? We have 25, we have 50, and then we have 75, and then we have 100, and then we have 125. So we have 525 out of 125, and then out of 100 we actually having a 4 there. So basically, if we were to convert this whole thing, it's going to be supposed to be 4 over a 5, or we can test it with a calculator. I hope you're actually getting this, that we actually got this, which we got it from here, which is, this is the correct. If you are getting it, just send a thumbs up. If you are not getting
So
it,
can you please explain 1,25?
Lega 1,25.
E.
Or you want me
Yes.
to do it again?
Yes.
Okay, let's start again. This is what I get paid for, guys. You have a right to ask a question. I'm gonna get paid. If you don't attend the class, I'm gonna get paid. Don't worry about it. And if you're not asking questions, I'm gonna get paid. So that's what is important. So what is important? Ask questions. If I get annoyed by your questions, then I'm not doing my job. I need to be fired. So you have a right to ask questions. So how do we end up doing this whole thing here? The first thing that we said that we want to convert it to a mixed number or a mixed fraction. You getting it? So, and then when we are actually, I don't know why this thing is just like this. So the first part here is going to be the whole number, and then we have a numerator, and then we actually end up having a denominator there, right? So these two are easy because we are taking them from there as they are. So here, the whole number, the number before the comma, is going to be a 1. So here you place a 1 as it is, and then the numerator, you take the number after the comma as it is. You don't change anything. So here we're supposed to end up having a 25. And then when we are dealing with the denominator, you place a 1 here. And then after placing the 1, you want to find out how many zeros do you have here. The number of zeros is determined by how many numbers do you have after the comma. You can see that I have 2 and 5. So there are 2 numbers after the comma. So here you are going to place 2 zeros for 2 numbers. That's what you actually do. And then once you are done with that, then you want to change this to a fraction. In other words, you want to only have now the numerator and the denominator. That is what is important here. Now, how do you get the numerator? The numerator, you get it by, you take this whole number here, you multiply it by 100. So 1 times 100 is going to be 100, right? And then now once you get that, you add 25. So you wanted to have 1 plus 25, right? But now to add it like this, I can't do that. I wanted to use tens and units, but in a shortcut. So I wanted to add 25, right? So when you are writing a number that you are adding here, since I wanted to add from 100, right? And I want to add 25. So when I'm writing this number below this number, I'm always gonna start with this 5 here, right? So I'm going to place a 5 and then place a 2 because there is nothing here. So there's nothing here, or there is a 0. You get what I mean? So we start with this one, which is the last one. So if, for instance, I'm just gonna make an example. If, for instance, I was adding, let's say I had 100, and then I wanted to add, let's say 200 and 2611, for instance. So when I'm writing here I want to add, I will start with this one here, the last one, and then follow by this one, and then follow by 6 here, and then I follow by 2 here, so that this last one is matched with the last one. And then when I'm adding, I'm gonna add them like this, and because there is nothing here, it's going to be 0 plus that number. So here I have 0 plus 5 is going to be a 5, and then 0 plus 2 is going to be a 2, and then I have 1 plus, there is nothing there, so I'm going to say 1 plus 0 is going to be a 1. So here we have 125, and then the denominator is always going to be that 100 as it is. So that's how simple this is. But now between 125 and 100, there is a common factor. If there was no common factor between the numerator and this denominator, this was going to be a final answer. And how do I know that there is a common factor here? Of course, I have to admit it is because I've been working with these numbers for a while. But what are the factors of 125 and 100? So the factors of 125, we know that 1 goes to 125 125 times, and 2 does not go there, because if I'm saying 125 and I'm dividing by 2, I will get a fraction. I don't want to get a fraction. So, and 3, if I'm going with the 3, you can see I'm getting a fraction. So you list all these factors of this. It can be 1 and 5 and 25 and also 125. So because I'm looking for the common factor, what is the factor that this one is sharing and this one is sharing? So I started with the highest that is possible here. So the highest that is possible is going to be 125. 125 goes 1 time to 125, but 125 does not go to 100. So 125 I cannot use it. So I go to another one, the one that is smaller than 125, and then the one that is less than 125 is going to be 25. So if I'm using a 25 here, how many 25 do we have out of this? So I have 25. If you have a calculator, this is a shortcut because you always have a calculator. So if you want to find out the factors, you can just say 0 plus 25. So it's going to be 25. The first is 25. The second is going to be a 50, and then the third one is going to be 75, and the fourth one is going to be 100, and the fifth one is going to be 125. So that's how you get all these factors. And here you can see that 100 is part of these multiples of 25. So here, how many times does 25 go to 125? 1, 2, 3, 4, 5. So it goes 5 times. And how many times does 25 goes to 200? Because when we are going to 100, we're going to end here. So it's going to be 1, 2, 3, 4. So we have a 4 there. Do you get it now? Okay, thank you. Now I want us to actually go to something else. What is important here that I want you to note is this. I don't want you to get confused with this. I'm just going to explain it. You know how to deal with 0,3. And I said that 0,3 is the same as 0,3000000. It doesn't matter how many numbers are. If these numbers are just zeros, then the number that you have after the decimal, you have one number there. So you're always going to have a 10. So if I'm saying to you, convert 0,300, I don't want you to end up saying that, oh, the whole number is 0, and then the numerator is going to be 3,000, and then now you are dividing by how many numbers are there? 1, 2, 3, 4. So you're gonna have 1 and then 4 zeros. I don't want you to do that, because having these zeros, if it's only zeros, then it is the same as just leaving them out. So in this particular case, even if you can do that, you can see this 0 and that 0, these zeros will actually cancel out. We have 3 zeros cancel, we have 3 zeros cancel. You're still gonna end up having that 3 over 10 either way. So once you have only zeros, don't say that the numbers there, you count also these zeros. No, you count from this number, and then you count all the numbers if there is another number there. So in this case here, this one here, these zeros don't even matter. But if I am saying 0,301, then because there is a number after 0, then you have 3 numbers there. But if there are zeros, you only have 1 number there because 0 is just a 0. I hope you can get this. If you don't get it, please tell me now so that we can move to something else. Okay. Let us move now to the conversion of fractions to decimals. Just gonna take 3 examples and then see if I can. I'm going to give you one example and then give you one question so that you can do it and tell me the answer. And then after that, I can give you another example and then give you a homework if we still have time. If we don't have time, and then we can call it a day. Of course, you're still gonna have an extra lessons that focuses on doing the problems of this, so it's still going to be fine. This one is actually the conversion of fractions. So when we are dealing with fractions now, fractions, I'm talking about proper fractions and improper fractions. That's what I'm talking about. And of these to decimals. Right. So if you look into this one here, suppose now I am actually giving you this is saying express the following fractions to decimals. Sometimes the question will go like convert the following decimals to convert the following fractions to decimal. It's either express or convert. So I want you to know that. So the first question is going to be, I want you to convert 1/5. And this one, I want you to convert it to a decimal. And then the second one here is going to be, I want you to convert 5/4. And then from there, I want us to convert the C. C is going to be 3/4. And then after that, we will also have our D, and our D is going to be, I want you to convert 7/8, right? And then the third one, the last one, is going to be, I want you to convert let's say I have 8/10. Yeah, I think these are actually fine. So let's start with the first one here. How do you end up converting this to a decimal? The first thing that you actually need to do here is this simple thing here. You ask yourself, how many 5s out of 1? How many 5 can you take out of 1? Can someone answer me that there? How many 5s out of 1? You can just open your mic and tell me. How many 5s out of 1?
Zero.
How many 5s out of 1? Bangapo 5 ku 1.
I'll go 5.
I'll go 5. Okay. To say that abeko of 5 ku 1, you place a 0 to say that there is no 5 out of 1, and then you place a comma there. That's how you say it in maths.
0.
So you just say 0 comma to say that you don't have any 5 out of 5 and out of 1. And then after that, you add a 0 there. And then you ask yourself, how many 5 out of 10?
2, 5.
2,
Two,
5.
two,
2,
five,
5. Is there a remainder?
There's no remainder.
There is no remainder, which means 1 over 5. This simply means that 1 over 5 is the same as 0, 2. That's what this thing is saying. 1 divided by 5 is the same as 0, 2. That's how you convert this whole thing. Do you want to try this one, or you want me to do it?
Do it.
Do it. Okay, it's fine. Okay. How many 4 out of 5?
1.
You have 1.
One.
You have
1.
you have 1.
1, 4.
Okay. You have 1, 4, and then you place a comma there. You get what I mean? And then after that, once you take the 4 out of 5, what will be the remainder?
The remainder is 1.
So you go, yeah, you will end up having a remainder of 1, and then you add a 0 there. How many 4 out of 10?
2.
You have
2, 4.
Two is remainder.
yes, and then you end up having, you have 2 4s, and then the remainder is 2, because you have 4, 8.
Two is the
It's 2, and then in that in that remainder 2, you add a 0 there. How many 4 out of 20?
5, 4.
five.
You have a 5 there.
5.
What is the remainder?
Five. No remainder.
There is no
There's
remainder.
no remainder.
This means that 5 over a 4 is equal to 1,25. You can test it here. 5 divided by 4 is supposed to be 1,25. And then let's try this one. Can you try this one and then give me the answer? Just try it. Are you all getting 5,7? What are you getting, guys?
0,757.
So no one is getting this correct answer here. I am telling you this is the correct answer. And there is no way a whole doctor can be wrong. I'm telling you as a doctor that this is the correct answer. So there is no way a doctor can be wrong. It's either the student or
No, the doctor is wrong.
it's either the calculator
No.
is okay.
Doctor is wrong.
No,
Let's try.
doctor is wrong.
Let's try and see if we are getting let's try and see if we are getting this answer here. So how many 4 out of 3?
Zero.
No, 4.
We have 0,
0.
and then you place a comma there. After placing a comma, you add a 0 there. How many 4 out of 30? We have 4.
7.
7, 4.
Okay. We have 7, 4. What is the remainder?
2.
7. We have 4, 8, 12, 16, 20, 24, 28. So the remainder is 2, right? And then you add a 0 there in that 2. And then how many 4 out of 20?
5.
You have 5 of them. This simply means that 3 over 4 is the same as 0.75, or someone might just say that it is 0.75, right? Because 0 is just 0. So whether you're writing like this, you're fine, or writing like that is still fine. Do you get it? Yes. So what I'm going to do now, I am going to give you these remaining ones as a homework. Try and do this, and then I'm gonna add maybe 2. I'm gonna add an F here, and then I'm gonna say that you have I want you to convert let's say 11 over 10, and then I'm gonna A, B, C, D, E, F, G, and then I'm gonna say convert let's say I'm just giving you 3 over 3 over 10, 100. So this is going to be your homework. Any questions so far? We're gonna stop here, and then tomorrow we'll talk about the addition of decimals, subtraction of decimals, multiplication of decimals, and of course the time is 12:30 tomorrow. So we'll have our class at 12:30 tomorrow. Any questions so far?
No.
Oh, okay. I'm gonna assume that you understand, because I'm gonna understand my payment when the time comes. Hopefully that you are also understanding your content, because we are actually running a business here. So this business is like this. You pay your fees. This is what usually happens. Let me explain this because we still have 3 minutes. When you are paying a registration fee, the meaning of a registration fee is saying whoever is going to be teaching you must start preparing the content. You get what I mean? And then once you have paid it, which means now you need the product, so you need to have information. And then the second part, when you are paying your tuition fee, you are actually saying that I am ready to learn. Whoever this guy is or whoever this lady is, he must come forward and teach me. So if you are sitting there and you are saying that no, I will get it myself, that's just you going to Checkers and saying I'm just gonna leave my 10 rand here without bread. That's actually how this thing actually goes about. And also the second thing is, when you're actually not getting this thing in class, you can always book a consultation. It's always fine. Once we are back to normal, I'm always gonna be available in my office. You can just go upstairs there, close to the secretarial, and the HOD's office is F102. I will be there. But if you are fine, we have faces. The faces are there. They are doing a wonderful job. So you can always consult even with them. They will explain this thing nicely. And I think that will be the end of today's class, unless you have a question. If you don't have a question, and then I think we're gonna end there. Okay, that will be the end. Thank you, guys. See you tomorrow. What time is it by Nancy Kenyam, baby?